All right, College Algebra, Lesson 1.5, and we're looking at quadratic equation applications. Looking at applications of how these quadratic equations exist in real life. Right here on number 1, we're going to start with this parking lot. You see this parking lot with all these cars in it. And it says, for the rectangular parking lot of the shopping center shown, which of the following equations says that the area is 30,000 square yards? Okay, so you can see on here my dimensions. This is x right here, this width. And then this length right here is 4x plus 400. Okay, now to find area of a rectangle is length times width. So here's my length and here's my width. So if I multiply those together, my length is 4x plus 100. My width would be x. And if I multiply those together, that would be my area, which is the 30,000. So this would be an equation that shows the area of this parking lot. So let's look up here. I think it's A. Yeah, right here. The answer is A. All right, so all we're doing on these first couple ones are just setting up an equation. And then, of course, once I set this up, if I distribute this x on here, 4x times x would be 4x squared, and then 100 times x would be plus 100x equals 30,000. And see, we got x squared. This is quadratic. And so we would do the quadratic formula to solve it. But that's all we're doing is just setting it up. That's my answer right there, A. Look at number 2. To solve for the lengths of the right triangle sides, which equation is correct? All right, which equation is correct down here? Well, if you look at this triangle, this is a right triangle. And anytime you have a right triangle, you have the Pythagorean theorem. A squared plus b squared equals c squared. And c squared, c is the hypotenuse. And if you look at the triangle, here's the right angle. So these two right here are my legs. And right here, this is the hypotenuse. So this is c, this would be a and b. A and b, it doesn't matter which one's which on those. But so if I just put this in for a, I got x squared. If I put this right here in for b, and then I put that in for c, and that would be my equation. And see which one is that here. No. I think it's D. Yeah, D right there. The answer is D. Okay. Oh, scoot over a little bit. All right. Now, let's go number 3 here. Number 3, we're setting this one up too. The mat and frame around the picture shown measures x inches across. Which equation says the area of the picture itself is 700 square inches? Now, this is the picture itself. Okay, now if you notice in here, this x, this is the frame going around the picture. So this is how thick the frame and the matting is. Okay, so we see here, once the frame is made, it's 40 inches long and it's 23 inches tall. Okay, now how big would the picture be? How long is the picture and how tall is the picture? That's what we don't know. Well, what we do know is this: since this is x right here and it's also x up here, then the width of this picture is going to be 23, because this is 23 tall, minus whatever that is and minus whatever that is. Like let's just suppose it's 2 inches. Then that means it's going to be 23 minus this 2 down here and minus that 2 there, which would be 23 minus 4, which would be 19. It would be 19. Whereas if this was like 3 inches, then it'd be 23 minus 3 and minus 3, which would be 23 minus 6, which would be 17 inches. Okay, but whatever this frame width is, this length right here is going to be 23 minus 2 x's, whatever this x is. Now, how long would it be here? All right, well, the length of this picture with the frame is 40 inches. And it's the same thing. I got this value here and this value here. I'm going to have to subtract off. So if this is 2 and that's 2, then it's going to be 40 minus 2 and 2, or 40 minus 4, which would be 36 long. Or if this is 3 inches thick, it'd be 40 minus 3 and 3. See, 40 minus this 3 and 40 minus that 3, or 40 minus 6, which is 34. But whatever x is, whatever this width of the picture is, the length of the picture is going to be 40 minus 2 times whatever x is. So here's my length and my width. Okay. It says the area of the picture is 700. So here you go again. Area is length times width. The area is 700. The length, okay, is going to be 40 minus whatever the x is, 2 x's. The width is going to be 23 minus 2 x's. And the area is 700. And that's how you would set this up. And that looks like B. Yeah, B. Okay. So that's the first three, just setting them up. Now, number 4 here, we're actually doing one. And this one's not too bad. This is the area of a rectangular wall of a barn is 24 square feet. It says the length is 8 feet longer than twice what the width is. Find the length and the width of the wall of the barn. Okay, so here's my wall of the barn here. This one wall. This is like a little barn, you know. And we want to figure out this wall of this barn. Okay, so it says the area is 24 square feet. Okay, so we know the area is length times width, and so we know the area is 24, which is your length times your width. Okay, now if you look over here, it says the length is 8 feet longer than twice the width. As I read this right here, the length is 8 feet longer than twice the width. I quickly realize that the width is the smaller of the two, because the length is 8 feet longer than twice what the width is. So since the width is the smaller one, I'm going to let the width be x. Okay? Now, what's the length? All right, it's going to be 8 feet longer than twice what the width is. So it's going to be 2x and then plus 8. That's what my length will be. And so these two should equal 24 if I multiply those. So let's set that up then. My length, 2x plus 8, times my width, which is x. That should equal 24. And so I've got it set up kind of like we did in the first 3 problems. And now I need to solve it. So this one I have to solve. Well, first thing I do is I distribute here. So x times both of these. So x times 2x would be 2x squared. X times the positive 8 would be positive 8x. And that equals 24. Okay, and now you can see this is x squared, which makes this quadratic. So I'm going to have to do the quadratic formula, which means this has to equal 0. So I need to subtract 24 on both sides. So it equals 0. So there we go. We're ready to go at it now. There's my equation. Excuse me. Now I need to do the quadratic formula. So let's move this over. Bring some other paper in here. Okay. All right, so we're going to do the quadratic formula. So remember, I will write it out here. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, there's my quadratic formula. So I'm going to write it out now. with the blank parentheses, so I got negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Okay, and now I put my numbers in. So here's my numbers. Here's my a right there, 2. My a is 2. Remember, now 2 goes here and here. All right, my b is a positive 8. All right, that goes in there, and that goes there. Okay, and then my c is negative 24, and it goes here in that one spot right there. All right, so this is the same thing from lesson 1.5. Just using the quadratic formula. And now, after I get those numbers in, remember, there's 3 things. We've got this thing, we've got this inside here, and we've got this down here. We've got 3 things to do at one time. So on this, x equals, that's going to be a negative 8. In my radical, let's bring this calculator in here and figure this up. It's going to be in parentheses, 8 squared minus 4, and then I got a 2 in parentheses, and I got a negative 24 in parentheses. All right, 256. On the bottom, 2 times 2 is 4. So I did all 3 of these things. Okay. Now, after I do that, I got to focus on my radical here and see if that's a perfect square. So I'm going to do the square root of 256. Hopefully that's a perfect square, and it is. It's 16. So that means x equals negative 8 plus or minus 16 divided by 4. So this square root right here is 16. Okay. And now I can do my 2 answers. Remember, this always has 2 answers. So I do negative 8 plus 16, which is 8, divided by 4, and that gives me 2. So negative 8 plus 16 is 8, divided by the 4, that's 2. There's one answer right there for x. Okay. Now, what's the other one? So I do negative 8 minus 16, which is negative 24, divided by 4, which gives me negative 6. There's my other answer. Okay. But we can't have negative values for distances and stuff. So this is out. We can't have that one. So my answer for x is 2. Okay. All right, so let's go back over here then. X has to be 2. So there you go. My width would be 2. And my length, 2 times 2 is 4, and 4 plus 8 would be 12. And there you go. There's my width and my length. So my width is 2. My length is 12, and sure enough, we got this right. Okay. All right. Let's go to number 5 here. Now, I think the last of these, I think that's all. Let me refresh my memory here. I think, yep. All right. So the last of these we're doing is called vertical motion. And let me do a little explanation here first. Okay. All right. Here's a person on the ground. Okay. He's got a ball. So he throws this ball in the air. When you throw the ball in the air, it goes up, and then it comes back down and hits the ground. Okay. Now, what makes this ball come back down? Gravity. Gravity is an accelerator. Gravity speeds you up. You don't fall at the same speed constant. Gravity is an accelerator, so it speeds you up. So that's why, if this is a chair, and if you're standing in this chair and you jump down, you don't get hurt because there's not much distance there for gravity to speed you up. But now let's go up in this tree. Here's this tree. Let's say you're in the top of this tree and you want to jump down. All right, now there's a different story because there's lots of space right here where gravity can speed you up which means you hit the ground faster, which means you're going to hit it at a harder impact, which could cause you to break your leg or maybe even cause you to sustain death, injuries or whatever. I don't know, but anyway, gravity is an accelerator. It accelerates you. Okay, so gravity is one thing that takes place in this. All right, gravity is a constant of 32 feet per second. In this equation, it's half that. So negative 16t squared. This is how fast gravity pulls you down. It's negative because it's pulling you down. Usually we think of when something's going up, it's positive. When something goes down, it's negative. So this is gravity, accelerator. Okay, gravity pulls you down. It affects the function of this ball at negative 16t squared, where t is in time in seconds. Okay? Now, what else affects the way this ball travels? Okay? One thing that affects it also is the initial speed. How hard you throw the ball. It will affect how high it goes in the air. A little kid, you got a little baby or a little toddler, he throws the ball in the air, well, he may not throw it very high at all. He can't throw it that hard. Okay? You take a Major League Baseball player, he may can throw this ball up for miles. I don't know. Maybe not miles, but you get the point here. So how hard you throw the ball makes a difference in how high it goes. Okay, so we call that the initial speed or the initial velocity of how fast it takes off. The faster it gets thrown, the higher it goes up in the air. Okay, so we call that our initial velocity. Now this can change. Gravity is always this right here, always. As long as we're on Earth, it's always this. Now, if we go to the moon, this changes because gravity on the moon's different. But the velocity depends on who's throwing the ball or how they're throwing the ball or whatever. This can change, so this changes depending on the scenario. But it does affect how high the ball travels. And then there's one third thing that affects the travel of the ball. Okay, and that one is the initial height. All right, now if you go back over here, this man, he throws the ball. Well, look where the ball is. It starts right here at a different height. Whereas this little kid here, the ball starts down here, so it's not as high starting out. Okay, now, if you take a scenario like this, here's a ladder, okay? And now this man's on top of the ladder. He's got this ball, and he throws it in the air. Well, the starting height is different. So you can see this one here starting higher, it's going to go higher because it started higher. So the initial height also comes into play. So, starting height. And this changes. So depending on the problem. So when you set up this problem, you always have this right here. This is what gravity does. You have your initial velocity and your initial height, which could change. These two change depending on the scenario of the problem. But they affect how high the ball travels or whatever it is that you're throwing up in the air or dropping if you just drop something. Okay. All right, so this is what happens with what we call, this is called vertical motion. When something is being thrown up in the air or something is dropped or whatever. Okay, so if we look at this problem number 5 right here, a projectile is launched from ground level with initial velocity of v sub 0 feet per second. Neglecting air resistance, and now that's one thing too, see, air resistance, that could come into play. If it's windy out, that could affect the ball traveling and how high it would go and how long it would take to hit the ground. Anyway, its height in feet t seconds after the launch is given by this right here. This is my equation for this. You can see the negative 16t squared, that's the gravity. And then plus v sub 0t, that's your initial velocity, like we just talked about, how fast you throw this ball. Find the times that the projectile will reach a height of 400 feet and return to the ground when v sub 0 is 128 feet per second. Okay, so here's my initial velocity. This is how fast the ball was thrown in the air. Okay, now let me go back to this picture here to explain to you. Okay, once this ball is thrown by this person, all right, if I was able to just do a snapshot 1 second into this, 1 second, the ball might be right there. All right, so if I was to put 1 in this equation, it would give me whatever height this is. That height might be 20 feet. Okay. If I was to be able to just snap and stop motion in 2 seconds, the ball might be right there in 2 seconds. And whatever height that is, that could be like 30 feet or 40 feet. I don't know. It depends on the problem. Okay. Now, how many seconds would it be until the ball is 30 feet high? All right, well, let's say right here, this line right here is 30 feet. All right, so if you look at the picture, at 30 feet high, the ball could be right here on its way up. But it goes up, and then it comes right in, and then right there, again, it could be 30 feet. So there's 2 instances where the ball could be 30 feet high. So that's why there would be 2 answers on this sometimes. Okay? Now, if you look at this right here, the max height, whatever this max height is, the ball is just there once. So here you would just have 1 answer. And I don't know if we'll have one like that or not, but it's possible. But most times you have, at a certain height level, you have 2 answers. So we want to understand that. And that's what we might have on this one here. I'm not sure. All right, so let's try this now. So we've got S. All right, S is the height, and it says find the time that the projectile will reach 400 feet. 400 is my S. So I'm going to do 400 equals negative 16t squared. All right here. 400 is my S. Negative 16t squared plus v sub 0t. V sub 0, it says right here, is 128. So this is plus 128t. Okay, and I want to solve this, which is quadratic. See, I've got a t squared. So I'm going to have to minus 400 on both sides because it's got to equal 0. All right, so 400 minus 400 is 0. And if I notice now, nothing over here goes together, and there's no like terms, so I got to keep all these separate. And so there you go. There's my equation. So I'm ready to do the quadratic formula. All right, so let's do it right here. Okay, I'm going to move this up just a hair. All right, so x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, there you go. So my a is negative 16. Negative 16 goes here and here. B is 128. 128 goes there and there. And then negative 400 is my C, and it's just in that one spot there. Okay? All right. And then when we do this, remember now we have 1, 2, 3 things that we got to do. Okay, so right here, x equals, that's negative 128, plus or minus in my radical. All right, let's punch this in here. 120, oops, hold on, forgot my parentheses. 128 squared minus 4 times negative 16 times negative 400. Okay, negative 9216. Down here, 2 times negative 16 is negative 32. Okay, now we focus on my radical. And I see a big problem right here. See this negative? When we do a square root of a negative, you know what that is? It's imaginary. So that's going to send out an imaginary, which means I have negative 128 plus or minus I. And then I'm not even going to mess with it from here. But there's an I in this, which means it's imaginary. Which means there's no solution here. This ball was thrown at 128 feet per second. It wasn't thrown hard enough. And it's not going to make it up to 400 because this comes out to be imaginary. So the answer is B here. The projectile does not reach 400 feet. It was not thrown hard enough. Okay. And there you go, see. Now, part B, the projectile returns to the ground after how many seconds? How many seconds does it take for it to return to the ground? All right. So let's look at our picture here again, maybe. When you throw this thing in the air and it comes back down to the ground, all right, when it hits the ground, what's the height of the ground? How high is the ground here? All right, in all these problems, ground height, ground height is always 0. So your height, S, is always 0 for ground. Ground is always considered 0. So if I continue on here, when does the projectile return to the ground? Which that means right here for S, I'm going to put 0 there. So when I have 0 equals negative 16t squared plus, remember now V sub 0 is 128t. Okay, and so I have this right here. All right, and so it already equals 0, so I'm ready to go. Now notice on here, here's my A, there's my B, and look here, there is no C, so C is 0. Okay, so when I do the quadratic formula, I'll put 0 in for C. So let's do it here. Oh, you know what? I did X up here a while ago. It should be T in this problem. We're doing T, so I need to do T. I didn't think about that a while ago. So let's do T. T equals negative B plus or minus the square root of B squared minus 4AC all over 2A. Okay. And now this time, my A is negative 16, so negative 16 goes here and here. My B is 128, that goes here and here. And then my C is 0, that's a big 0 right there. Okay. And so now I've got 1, 2, 3 things to do. All right, let's see here. Let's do T equals negative 128 there. Down here, this is negative 32. Okay. And then let's do this in here. So I've got 128 squared minus 4 times negative 16 and times 0. And look there, 16,384. Okay. Now, after I do all those 3 things, I focus on my radical here. Is that a perfect square? So let's try doing that. So we're going to do the square root of that answer there. And yeah, it's 128. So there you go. T equals negative 128 plus or minus 128 divided by negative 32. All right, so this right here is 128. Okay. And so now I do my 2 answers. So first answer, negative 128 plus 128 is 0. And 0 divided by negative 32 would be 0. So t would be 0. And then the other answer, negative 128 minus negative 128 is negative 256. And here, we'll just do it on here. Negative 128 minus 128 is negative 256. And then divide that by negative 32. And that's 8. So there's my two answers right there. T equals 0 and t equals 8. 0 and 8. Now, if you look at our picture here, like we did a while ago, this projectile is launched from ground level. Listen, see here? It's from ground level, which means there's no person that's starting right here. So it's on the ground at t equals 0. So that's what the 0 comes from, see? Here, let me just draw it on here. That way you can see it all together. So here's this projectile. It started on the ground, it goes up, it comes back down, and it hits the ground. So right here, this is t equals 0 right there. If it goes up and it comes back down, and right here, this is t equals 8. So in 8 seconds, it hits the ground. Now, what's the question asking? It returns to the ground after 8 seconds. So the answer is 8. It returns to the ground in 8 seconds. Okay. Let's go to this next one here. Here's the astronaut on the moon. Throws a baseball upward. Now, like we talked about a while ago, the moon gravity is going to be different. And the astronaut is 6 feet 6 inches tall, and the initial velocity of the ball is 50 feet per second. The height s of the ball in feet is given by this equation. So here's my equation right there. And if you notice, negative 2.7, there's my gravity on the moon. 50, see, that's how the initial velocity, how hard it was thrown. And then plus 6.5, this astronaut is 6 feet 6 inches tall. So that's 6.5 feet, 6.5 feet. There's my equation for the problem. Okay. So, question A, after how many seconds is the ball 16 feet above the moon's surface? Now, so this is like what I mentioned earlier, that there's probably going to be two answers here. If you look back at my picture here from a while ago, let's say this is 16 feet right here. It could be 16 feet on the way up, or it could be 16 feet on the way down. So there should be two answers. All right, so let's see what they are. So 16 is my S. I'm going to put 16 in for S, so I'm going to get this. 16 equals negative 2.7 t squared plus 50t plus 6.5. All right, and it's got to equal 0 because, see, I got t squared, so I got a minus 16 on both sides, which makes this equal 0. And then over here, I got like terms here. So that's going to be negative 9.5. Okay. Which is quadratic. So we're going to do the quadratic formula again. All right. So let me see if I can put it on the other side. So let's move this over. There we go. T equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Well, you're going to be tired of that song. But I believe you're going to have it down, though, that's for sure. All right, in this, here's my a, negative 2.7. It goes here and here. My b is 50. It goes here and here. And c is negative 9.5. That's all the way at the end. Okay. And so when I put them in there, I've got this, and this. Those three things to do. All right, so that means t is going to be negative 50 plus or minus in my radical. Let's punch that in to see here. 50 squared minus 4, and then I got negative 2.7, and I got a negative 9.5. Okay, and there you go. Negative 77.6. Okay, and the bottom, we're going to do 2 times negative 2.7, which is negative 5.4. Okay, now, and this, every time we always look at this radical. In this problem, though, we're trying to figure out what the time is that it hits that height. So we're going to have to go ahead and just punch this in. All right, so there's no perfect square here. We're just punching it in because it does say round to the nearest hundredth. So what I'm going to do here then is I'm just going to use my calculator to do the whole thing here all at once. Instead of punching this in and then writing it over and then doing my two answers, I'm going to do all my two answers at once. Okay? I don't know if that makes sense. Let me show you. So I'm going to do negative 50 plus radical. Oh, wait a minute. This is negative. I don't think we did this right. I didn't realize I got a negative answer. We got to do this again. 50 squared minus 4, negative 2.7, and then negative 9.5. Yeah, we made a mistake here. I don't know what I did a while ago. You should have told me I made a mistake. All right, so this is, I'll just write it over. Negative 50 plus or minus, this is wrong, and the radical, 2397.4, all divided by negative 5.4. Okay, there you go. So now I'm going to type my two answers in. So I'm going to go negative 50. I'm going to do the plus first. I'm going to do radical 2397.4. And you have to hit equals. So you do this top right here and you hit equals. Then you divide by the bottom. So you divide by negative 5.4. And I get this right here, 0.191990458. There's one answer for T. Now what's the other answer? So I'm going to do the minus now. Negative 50 minus the radical 2397.4 equals. You always hit equals. You do the top, hit equals, then you divide by the bottom. And there you go. 18.32652806. There's my two answers. Okay, now if you look back at the problem here, it says after how many seconds will it be 16 feet above the moon's surface? This is round to the nearest hundredth. So I need to round this to the nearest hundredth. So remember, hundredth, 100 has two zeros. There's 100. 2 zeros, which means we're looking at the hundredth spots, the two decimal spots. So we want to keep these two decimals. Now you look at this third one here. Does that 1 make the 9 go up or stay? Well, it stays. So T equals 0.19 is one answer. Now on this one, I want to keep the nearest 100, so I keep these two. Now this next one, does the 6 make the 2 go up or stay? It goes up. 18.33. There's my two answers. And look there, man. I think we got them. Okay. Now, part B. How many seconds will it take for the ball to hit the moon's surface? So, it's going to hit the surface. So, what's the height of the surface? Well, that's the ground level. It's 0. So, I'm going to put 0 in for S, which means I'm going to have this. 0 equals negative 2.7 T squared plus 50T plus 6.5. And there you go, already equals 0, so we're good to go. So we can just go ahead and do a quadratic formula. Let's push this up some. All right, T equals negative B plus or minus the square root of B squared minus 4AC all over 2A. All right, here's my A right there, negative 2.7. Goes here and here. My B is 50. It goes there and there. And then I got C, 6.5 over here at the end. Okay. So I've got 1, 2, 3 things to do. So t equals, that's negative 50 right there. Down here, 2 times negative 2.7 is negative 5.4. And my radical, all right, let's get the calculator here. 50 squared minus 4, and then negative 2.7, and then 6.5. All right, 95.2. All right, and like I said on the previous problem, we want to get the actual number here, so I'm going to go ahead and punch this in. All right, so let's just go ahead and clear that off. And negative 50. Okay, and then I'm going to do the plus first. Radical 95.2. Remember, I got to hit equals now. I'm going to do this top. And I divide by negative 5.4. And that's going to be 7.452398. I don't think that's right. Did I make a mistake again? I don't know. Let's go up here. Did I? Oh, look at me. Why didn't you tell me I made a mistake? My light is so bright I can't see my calculator when I do this. I hit. What a dummy. All right, so let's go ahead and change that. 50. There you go. Yeah, that's more like it. So let's do this over. Negative 50 plus or minus the square root 2570.2, all divided by negative 5.4. Okay. You got to be able to see your calculator. I got this light, and I can't even hardly see the calculator. But let's see here. So I got negative 50 plus radical 2570.2 equals. You always hit equals when you do the top. Then you divide by negative 5.4, and you get there you go, which is negative, and you can't have negative time, so that's out. You can't have negative time. Well, there's lots of times I wish we could go backwards in time and redo stuff, but we can't. But that's why I knew this was wrong, because usually when you hit the ground, there's only one answer. It only hits the ground once. And so usually the plus one is always minus, a negative. So I knew that was wrong because it wasn't negative. All right, so now we do the minus one, which here should be my answer. So negative 50 minus the radical 2570.2, hit equals, and then you divide by negative 5.4. And there you go, t equals 18.64761.851. And we're going to round this 2 places. And so we're going to keep these 2 right here, which means, look at this one. Does the 7 make the 4 go up or stay? It goes up. So 18.65. And there's my answer right there. Okay. Now here's another one, exact same one. You could try this on your own. Here's the answers. Okay, it's the exact same problem. Just a little bit different numbers. All right, so you can pause this. There's what the answer is. And maybe you can get that. So this concludes our lesson here. Quadratic Equations Applications, Lesson 1.5. If you have any questions, please let me know. I'll try to help you all I can. So I hope you have a good rest of the day.